welcome to today's webinar. Thanks for joining us. My name is David Simpson. You can see my information there on the board. You can get a hold of me at the email address listed there, dsimpson@themisinc.com. You'll see a couple other ways to find me shortly. So the topic for today is Db2 for ZOS, altering tables with high availability. This is something that I actually talk about with my clients quite a bit, and has been a focus in recent releases of Db2 for large-scale environments that never stop. Right? How do we get changes into that environment in the most unintrusive way? So I'm going to try and talk about the evolution of that over the last few releases of Db2, and also point out where some of the challenges still lie, and there are several. Okay, so word from our sponsor for today, my company, Themis Education. So what you're seeing here is something that we do quite a bit in terms of education. We teach all kinds of things across the spectrum of IT and software development and all of that. My focus is usually on Db2, although I do some of these other things as well. We do training everywhere, right? You can sign up on our public schedule for classes, and we also will come to you if you have enough people. So love to hear from you if you kind of want more of what you're seeing today. Also, at the website down at the bottom there, themisinc.com/webinars, you can see upcoming webinars there, and also if you'd like the slides from today's presentation, I'll show you what that looks like. So if you go to our website, themisinc.com, and select webinars at the top, you'll see past webinars. You can see the replays from webinars that we've done in the past, but also you can get the slides from today's presentation. Should be right front and center there. There's a button that says get the slides. And so those are all there for you. So feel free to take advantage of that. A little bit about me. A lot of you, I recognize a lot of the names of people showing up here today. So a lot of you know me. I've been doing this for a while now, since about 1993. So I started out with Db2 version 2. something, 2.3, I think, when we could alter, practically nothing. And been watching new releases go by ever since then. Worked as both a developer and a DBA in the real world, and then about for the last 12 years or so, I've been doing this training and consulting thing. So seen a bunch of different angles of Db2. I've said this before, but people ask me why I started doing this training thing, and the answer is usually that we don't have training emergencies as much that would involve me being up at times that I'd rather be sleeping. So get to speak to clients all over the place, all over the world really now, and so that's kind of where I'm coming from. So the agenda for today, we're going to look at a little bit at the history of the alter. History lessons aren't terribly exciting, but we're just going to look at what we've been able to change about Db2 tables over the years and how IBM's philosophy of working changes into our environment has changed in recent years, and then talk a little bit about what that looks like today. We'll also look more specifically at some things that come in Db2 version 12. So those of you who are either getting to 12 or planning to get to 12 pretty soon, we'll be able to take a look at as well. Right? And then how does all this work for high availability? So history of altering things on Db2. So really from the beginning up until about version 7, so we're talking about 15 years ago now, was version 7. Not a lot had changed, right? And you could change very little, right? We could add columns to tables. We could add or remove primary keys. We could add or remove foreign keys. We could change space allocations and free space and the compression attribute. And there were other, less interesting things that we could do. But the actual structure of the table, really all you could do was add columns and change the keys. We couldn't remove a column. We couldn't change a column's data type. We couldn't change anything about partitioning for our larger tables, which was something that when it was important, right? One of the first things when I first became a DBA in 1997, the first thing that the people who were there before me did was hand me a table that was a segmented table space that was getting full. And they said, this needs to be partitioned. It's, you have a few weeks before it fills up, the space that was available in the segmented table space at the time. And, I asked them, what's the alter for that, right? What's the way we make that change? And they laughed at me and, let me know that I was going to be spending weekend time there dropping and recreating. So it was really precious little we could change, especially some very important things like, column data types, column defaults, and partitioning stuff. So version 8 was, the first release where they started tackling this in a big way, and they called it at the time online schema evolution. Just fancy words for you can alter more things without having to drop and recreate. Right? So they gave us in version 8 the ability to change a data type, bunch of rules. Right? Basically, with incompatible data types, you can get bigger but not smaller because we don't have the possibility of data loss. Right? So you can go from small integer to integer, but not the other way. You can go from decimal 11 to decimal 13, but again, not the other direction. We'll talk about the implications of that in just a minute. And in version 12, they're making a change or a potential change to how that's going to work. But for the first time, we could actually make changes to data types, sensible changes to data types, without having to drop and recreate the entire table. They also gave us the ability to add partitions to a partition table space. That was something I needed in the beginning, but didn't get till version 8. Rotate partitions, something less common, but if you're doing a date-based partitioning scheme, can come in really handy. Version 9, they gave us the ability to rename columns. Not much else going on there. That's, a fairly simple change. Of course, it doesn't go rewrite your applications, right? So could be a bunch of application changes associated with that. It's really just catalog work. Version 10 got all kinds of new changes, and this is where they introduced the concept of what we now call a deferred change, which we're going to talk about in detail in just a second. So things like the page size of a table space. You're currently on 4K pages in a 4K buffer pool. You want to go to 8K, you can do that now. Changing seg size or DS size of the underlying objects. First time we were able to do that without a drop. We can also migrate legacy table space types to universal with a bunch of rules. So if you have a simple or segmented table space, you can now do an alter that will convert that to a universal partition by growth. If you have a classic partition table space, you can, with a little bit of work, convert that to universal partition by range. Okay, so universal table spaces, hopefully it's clear to everyone now that that is, the future. The legacy types are all still supported, but new features are all going into the universal ones, including the ability to do some of these nifty alters that we're about to talk about. Version 11, we can remove columns. Notice, big change between version 10 and 11 is that the B in DB2 went lowercase. a very expensive marketing change that they made, and a pain for any of us who develop material or write articles on a regular basis. Version 11, we can remove columns. You can also alter partition limit keys. That was something that they gave us, back around version 7, the ability to change the limit keys of a partition table space. but they potentially give us a way to do that in a more online way in version 11. We'll talk about that in just a second as well. Version 12, we get this new ZPARM called DDL Materialization, which again we'll talk about in a second, and a change potentially in the way we do changes of data types. You're actually going to be able to control that with a ZPARM. Like a lot of things, or with the ZPARM listed there, like a lot of things that are ZPARM controlled, we might wish that they were not ZPARM controlled so that we could do it on a case-by-case basis. But so far, this is the way they've given us to do it. Right, and we'll get into detail in just a second. So here's the deal. Now, since version 10, whenever we're going to do a change, we have to ask ourselves whether it is an immediate change or a deferred change. And we should talk about what that means just a little bit. Prior to version 10, every alter that you would do was an immediate change, meaning there was some kind of immediate impact to either the Db2 catalog or the underlying page set that took effect immediately. It didn't necessarily mean that there were no lingering side effects. In other words, you could do an alter. Let's say you altered the primary quantity on a table space. That is an immediate change. It immediately is reflected in the Db2 catalog. The fact that the underlying data sets don't really change their primary quantity until you do a reorg or a load replace of that object is what I'll call it, a lingering side effect. It's actually kind of a big one in that case, right? The primary quantity isn't fully effectively changed. So an immediate change in Db2 is a change that has some effect immediately, right? Where the alter makes some change to the Db2 catalog or the underlying page set with immediate effect. Again, there may be lingering side effects, and some of these changes now may result in this status called AREO asterisk. Right? And we're going to look at the difference in the different kinds of advisory statuses also in just a moment. But this is a little bit misleading, I think, the term immediate here, because it implies that there is, the change is completed immediately, which is not necessarily true. Right? There may be a reorg or load replace may have some effect on fully implementing the change, but it is effective immediately, at least in some sense, in the Db2 catalog in particular. Right? So if we look at a couple of examples here of immediate changes, if you add a column to a table, that column is immediately there. Right? Applications will see it as soon as the alter completes successfully. Or pre-version 12, if we change a data type, that was immediately effective prior to version 12 anyway. So we changed the data type from small integer to integer there. Both of those changes will result in the AREO asterisk status being placed on that table space. It's an advisory flag. It doesn't prevent you from doing anything, but it is letting you know that a reorg will probably benefit the performance of that table space. In other words, if you have a 10 billion row table and you add a column to it, that column is not physically added to every existing row, right? And Db2 has to remember that the rows that were added prior to that alter have to be kind of padded out when you select them with the default value. So this is actually, can be a rather resource-intensive thing for Db2 to have to do on an ongoing basis. So it gives you that advisory reorg with an asterisk. Doesn't prevent any access, just is letting you know that a reorg would probably benefit you here from a performance perspective. Reorg sorts it all out, right? It'll go to every row in the underlying table space and physically add the default value for the column. Prior to that, it has to figure that out whenever you select a row. Okay, same thing with the data type change, right? If your column is small integer and you change it to integer, it doesn't go add 2 bytes to every row right away. It does that on reorg, but it has to then figure out every time someone selects a row, does the column affected need to be converted for presentation back to the user. Okay. Beginning in version 10, they gave us a new kind of change called a deferred or pending change. So one of the things that's going to be really important is to ask yourself, is the alter that I'm doing an immediate or a pending change? And in order to figure that out, you're going to have to look up in the book, or try it in a test environment, presumably. What kind of a change is this? And this can change from one release of DB2 to another, and it can change based on some of your zparm settings. It can change based on what kind of table space you're altering. So a deferred change is one that has no immediate effect, either to the baseline catalog objects or to the underlying page set. The changes become effective in the switch phase of an online reorg. When I say an online reorg, I mean share level reference or share level change if you're using the IBM utilities. If you're using the third-party utilities, it's going to be pretty important to figure out how they support this feature specifically. Some of them fully support it. Some of them end up just kind of calling back to IBM. You really need to look at your specific utility vendor and see how they handle a reorg when there's a pending change. So when you do one of these alters, the information about the alter is actually placed in a special catalog table called syspendingddl, and your table goes into AREOR status. Notice it's different than the AREO asterisk. And for a long time, I didn't really understand the difference between those two statuses. But the main thing is AREOR indicates that there's a change waiting to happen that has not happened yet. AREO asterisk indicates there's a change that already did happen, and a reorg would help it sort out for performance. All right, so I think I've got the documentation here, chapter and verse, that talks about all of the reorg statuses, which is the two that we've discussed, AREO asterisk and AREOR, along with actual reorg pending, which is bad. Reorg pending does take the table out of service, and there's not too many cases where you get that anymore, at least post version 11. Okay. So let's look at some common deferred changes that we may want to do. If you alter the seg size of a universal table space, that is a change to the underlying structure of the data in your physical page set, in your underlying vsam files. The only way that can actually be done is as part of a reorg. So I've broken these out into universal and non-universal. So if you have a universal table space, the stuff at the top is alterable via a deferred change. Change the seg size. If you change the DS size, the dataset size, that is a deferred change unless you're version 12 and you've gone to this new kind of partitioning called relative page numbering. So whenever I talk about this particular topic, it reminds me just how acronym happy IBM can be, right? We have a UTS PBR RPN, which stands for Universal Tablespace, Partition by Range, Relative Page Numbering. It's a new thing in version 12. And if you're that kind, then a DS size is an immediate change without all the lingering side effects. Okay. That, by the way, is going to be the topic of my next webinar, which I think I just scheduled today in March. So if you go to that webinar page, again, themisinc.com/webinars, I'll put that up again at the end since it didn't actually show at the beginning. But you can sign up for that. We'll talk a little bit more about the relative page numbering. You can change to a different page size if you're a universal table space. you can change partition limit keys in a more online way. So prior to version 11, if you altered the limit key of a partition table space, it put you in reorg pending. It put the affected partitions in reorg pending, and you had to do an immediate offline reorg in order to sort out what data went in which part. In other words, data had to actually move from one partition to another, or it was possible anyway that would happen. And a reorg is the only way to sort that out. And it put you in reorg pending, and you were out of service for the affected partitions until you accomplished the reorg. In version 11, they moved that change from the category of an immediate change with reorg pending to a pending change with advisory reorg pending. So in other words, you do that alter of a limit key now, and your data doesn't move, it just stays where it is. The application continues unaffected. When you accomplish that reorg, share level reference or share level change, then the data moves around between the different parts, and during the switch phase is when the actual limit key definitions are changed in the Db2 catalog. Okay. Drop column, I believe that was new in version 11. Also becomes a possibility to remove a column, and it is a deferred change for a universal table space. If you're not universal, then the scope of deferred changes is much more limited. And what I mean by that, I guess, is the changes above that are possible would be immediate changes with sometimes some fairly severe side effects like reorg pending, or they're just not possible at all. Right? I cannot change the seg size of a segmented table space. I can change the seg size of a universal table space as a deferred change. So about the only things I can do with non-universal table spaces, well, I can convert them to universal. So if you have a segmented or simple table space, it can be converted with a deferred change to universal partition by growth. If you have a classic range partition table space, it can be converted to universal partition by range. And that can be done with an alter and a reorg as a pending change. If you are table controlled partitioned, classic table controlled partition, you can do the limit key alters as a deferred change. And there's a couple of ZPARMs down way at the bottom that help you deal with that. It mostly help you deal with accidentally, help you prevent accidentally doing what you think is an online deferred change and having it end up being an immediate change with reorg pending. Number one, and these both deal with index-controlled partitions, right? Index-controlled partition table space. Those are the old kind of partitioning that we had. It was the only thing we had in version 7 and prior. We should not be creating any new ones of these, I think it's safe to say. And the ones that you still have, you should be thinking about converting them to universal, or at least to table controlled. And there's a fairly well documented process for that. I'll have a slide about it in just a minute. Let's do the second one first. Prevent new index controlled part. If you set that ZPARM, you're just not allowing yourself to create any new old style objects. I think that's a sensible thing to do. Prevent alter TB limit key. That says if I have any existing index controlled partition table spaces, do not allow me to alter the limit keys. It just fails. Negative SQL code, I don't remember which one. I think this is a good one to set as well. Now you might complain and say, well, but what if I need to alter the limit keys? Well, what you're going to have to do then is convert it to at least table controlled partitioning, which is a fairly simple change. And then the alter to the limit keys will become an online deferred change. Okay. The idea here is, though, you're preventing yourself from accidentally doing a change that you think is online that ends up becoming an immediate change with consequences. So I would check out those two ZPARMs, and I would recommend you set them both to the more restrictive status, which is to prevent those two situations. Okay. When you're converting tablespace types from one type to another, these are the paths. I said them verbally a moment ago. You can go from simple or segmented to universal partition by growth. It's a deferred change. A reorg will accomplish it. If you're going from classic partitioning to universal partition by range, you can only actually go there from table-controlled partitioning. Okay, so this change here from classic table-controlled to universal is a deferred change or pending change. The change from classic index-controlled to classic table-controlled is an immediate change. And it's an immediate change that in most cases doesn't have a lot of dire consequences, although there is an occasional oddity that will result in reorg pending. The normal way to do this change from index controlled to table controlled is if you take the clustering index and make it not clustered and then alter it right back to clustered. That is the most foolproof way of doing that won't result in reorg pending ever. All right, so here's a quick example. Got a segmented table space there. We know it's segmented, classic segmented, I guess, because we got a seg size, but we don't have num parts and we don't have max partitions. Right? Num parts would make it range partitioned. Max partitions would make it partitioned by growth. Since we don't have either of those, this is a classic segmented table space with a seg size of 4. And down at the bottom there, you see in the Db2 catalog, we see seg size of 4, and the partitioning information is all either blank or 0, meaning it's not partitioned. So we decide we want to convert this thing, right? Alter table space. This is something you could do in version 10 or after. Alter table space. Set the max partitions to a non-zero number, right? 4. And what's going to happen is this is going to return a +610 SQL code. +610 says, I just put your object in advisor reorg pending. So if we do a display, you'll see it in AREOR status. And if we look at the syspending DDL catalog table, you'll see an entry for this table space now with an object type of S. It's a table space. The option that we changed is max partitions, and we set it to 4. So this change hasn't actually happened yet. We ran the alter. It threw a row in syspending DDL, and it's going to actually happen at the next online reorg share level reference or share level change. Okay. To apply the changes, we run that reorg. And it's important to kind of note that the change happens is actually sort of physically done during the switch phase of that reorg. So it does have to be share level reference or share level change. Those are the two kinds that actually have a switch phase. And again, I'm assuming IBM standard utilities here. If you have third-party utilities, again, check and see how they deal with the situation. All right. During the switch phase, the table space type is converted, the pending restriction is removed, and the data is available throughout the process well until you get to that switch phase. And we got to talk about some of the other kind of consequences of this in just a minute. Here's another oddity that I've asked about and not gotten like a super clear answer. The seg size was 4, right? If you looked at my previous slide, if we go back a slide or two here, I created a segmented table space. Its seg size was 4. My alter did not change the seg size. And coming out of that reorg, I have a seg size of 32. This is just an oddity that I've found that you probably want to be aware of if you're doing a lot of conversion of segmented to universal. This is the only time this one comes up. If you're going from a segmented table space to a universal partition by growth. The seg size will take the default value, which unless your system person has changed the zparm is 32. Unless you also issue an alter that changes the seg size back to whatever you wanted it to be. So there was a weird side effect on this particular conversion that my seg size went from 4 to 32 for no particular reason other than they always do that when a tablespace conversion happens. All right. A little bit weird. The simple to universal, you're going to have to specify a seg size, right? And universal partition by range to partition by growth, the way I get there, or to partition by range, excuse me, classic range partition to universal partition by range, the way I get there is by giving it a seg size. But this is a weird case where it had a seg size before and it has one after, and I didn't change it and it changed it for me. Again, not entirely sure why, but that's what IBM does. But you can see the rest of the catalog tablespace entries now reflect that this is a universal partition by growth. And the advisory reorg pending was removed. Okay. So during this reorg, the updates are applied, the catalog is changed, syspending DDL row is removed. Another weird side effect here, and I understand this one a little bit better, is that statistics are automatically collected whether you ask for them or not. And it shows you the default there, right? Table all, index all, update all, history all. If you stick your own statistics card in the reorg, it'll override that. But I think they've decided that by default they want to get at least some level of statistics because the structure of this underlying object has changed in some kind of significant way, right? You get a ton of syscopy entries every time this happens. Advisory reorg pending goes away. And then a couple of things at the bottom there which we really need to talk about. Number one, your image copies from before that reorg are marked as ineligible. Version 11 dealt with this sort of, only in certain cases, and that's a pretty narrow set of cases. But I would assume if you're doing this migration, especially if you're changing the tablespace type, that the image copies that you had from before are no longer eligible to be used in recovery. It doesn't mean they go away. It doesn't mean you can't use them for anything. It does mean that you're establishing kind of a new earliest point of recovery, right? You're not unrecoverable. You just can't go back to a point before that reorg, okay? The second one there is probably the one that has more wide-ranging consequences, and that is dependent packages are invalidated. We say plans and packages, but they also made us go to packages now, right? So we really mean packages. Any package dependent on this object that we just reorged is marked invalid. And this is a huge issue for a lot of shops that I deal with, because we may reorg one table and have thousands of packages go invalid. So we're advertising this as kind of an online change, right? Low impact. Well, we do have the switch phase of the reorg to deal with, and we also have the fact that all the packages that touch it are going to be invalidated, which could be a lot of packages. We'll address that more, a little bit more in just a moment. All right, in version 12, I already talked about this a little bit. We have this new kind of tablespace called UTS, PBR, RPN, relative page numbering. Essentially what it means is that the page numbers in each partition start over at 0 again. Prior to this, if you have a range partition tablespace, the page numbers are unique throughout the tablespace. And the way they do that is, I learned a lot actually by just kind of researching this change. And I'm going to deal with that in the webinar that I've got scheduled for March. So again, sign up for that if this is a real interesting feature to you. The big thing this is going to allow you to do is scale, exponentially more, right? So the DS size, the maximum theoretical size of a partition, now becomes the maximum theoretical size of an entire tablespace prior. Right? So each partition can now use all the addressable pages for what used to be the entire tablespace. There's some costs and benefits of that. The side effect that I'm interested in discussing here is that the DS size, which used to be a deferred change that required a reorg to sort out all the page numbering, if you're a relative page numbering tablespace, is now an immediate change with no side effects other than you can go bigger. Okay. Packages are still invalidated. I don't quite know the reason for that. but I tested that out actually yesterday. And if you alter the DS size of a relative page numbering table space, even though the impact of that is kind of minimal in other respects, the packages are still invalidated. Okay, but it makes the DS size change, you know, pretty much a non-event other than the packages issue, which is, you know, maybe not insignificant. All right, other DB212 changes that are mostly deferred. Right, you can insert a new partition between two others in a partition table space. So previous to this, we could only insert new partitions at the end. Now you can put whatever limit key you want on it, and it will, you know, shift or stuff a new logical partition in between two others. Whenever you do that, the logical and physical partition numbers are going to get out of sync, which has the same kind of side effects of, you know, doing rotate partition. So handle with care, right? Adding a partition now moves from an immediate change to a deferred change. Okay, so when you do it, when you add that partition, it's going to potentially place you in advisor reorg pending for the affected partitions, because some data is going to have to move from old partitions into new. And that is now a deferred change. And on the tail end of that reorg, during the switch phase of that reorg, you may actually see, you know, partitions get created. Right? You come out with more partitions than you had before. Turning index compression on and off, now also a deferred change instead of an immediate change. Okay. Now, we also have to talk about this ZPARM in version 12. And this one, if you're already on version 12 or if you're thinking about going to version 12, this is one I think you should put a little bit of thought into. The ZPARM is called DDL materialization. It's got two values, always immediate or always pending. And it affects, the main thing it affects is the alter of column data types. If you alter a column data type, in other words, remember the earlier example where we said, take the small integer column and make it an integer. That was an immediate change in version 11 and prior. You went into AREO asterisk, right? The data type was immediately apparently effective to the users, but then there was that delayed, I really need a reorg to fix the underlying DB2 objects. If your DDL materialization ZPARM is set to always pending, then that will move that from an immediate change to a pending change. Okay. The benefits are, you know, well, I don't have any performance related issues, you know, related to the row versioning that I had before. It's going to kind of make you do the reorg to affect the change. And, you know, probably a more significant benefit, if the column you're changing is an indexed column, then it takes care of the index as part of that reorg, right? So in the past, you would have ended up in rebuild pending, right? If you did an alter to an index column, the index would be in rebuild pending because we got to figure out the index, right? The index has to be consistent with the data type of the table, of the column on the table. So that seems all good, right? The challenge, and so if your alters of columns are mostly on non-indexed columns, then this is a real big thing to think about. If you have large range partition table spaces, well, or partition by growth with lots of partitions, the materializing reorg has to be done on the entire table space, not at the partition level. And this is true of almost all of the deferred changes that we've talked about. The one exception being, you know, altering limit keys, the one I can think of anyway. Most of the time, it's going to require a reorg at the table space level. Now, you can do it at the partition level with the part level keyword on a listdef, but you have to do all the partitions at the same time in the same reorg, in the same execution of the utility. In other words, you can't have this change effective for some of the partitions but not others. They have to be done together. And some of you have large partition table spaces that are so big that reorging at the table space level is impractical or maybe impossible, right? So that's something to keep in mind. when you're choosing the value of the ZPARM. If you set it to always immediate and you do an alter on a non-indexed column, you're going to go into AREO asterisk, but then you can do those reorgs at the partition level one at a time if you want. And as you reorg them, the affected partition will come out of the advisory reorg asterisk status. So that to me is kind of a big deal, right? And this is why I said a minute ago, it would be great if, you know, things like this weren't a ZPARM, right? That I could decide on an alter by alter basis what I want. Because basically the choice is, if it's an indexed column, I'd really rather have the always pending behavior. If it's a non-indexed column, I'd pretty much prefer that it be an always immediate. Okay? I mean, that's maybe generalizing a bit too much. But the real issue that I can see is really large partition table spaces that are impractical to reorg at the table space level. If you go with always pending, that's what it's going to try and force you to do. All right. So put some thought into that as you go to version 12. Right. A couple other issues for high availability. You know, we have the usual outage associated with the switch phase. Right? And if you have lots of partitions, then this could be minutes long, right? Not, you know, not seconds or fractions of a second. So, you know, all of these deferred changes are going to require an online reorg, and you got to go through all of the issues of the switch phase. Again, if you're using third-party utilities, you know, check with them about how they handle all of this. When you do this, and every one of these that I've tested does this, the switch phase of the reorg will also invalidate all of the dynamic SQL statements in the dynamic cache, and it will invalidate all the associated packages in, you know, for bound SQL in the catalog. This can be a big deal, right? And I've got some of my clients that are basically saying, you know, we're talking about these as online changes, but they're not really online changes, because if 5,000 packages go invalid, it's going to take a while to rebind them. Okay, so you want to be thinking about that. The dynamic statement cache can be an issue, but you know, those statements as they come in again will get re-optimized, and it'll only be the statements that are affected. Right? The problem with invalidating packages is, you know, if you have a package that has 50 SQL statements in it, and only one of them has a reference to your table, you know, the whole package gets invalidated. So you're going to have to rebind the whole thing, which means I got to re-optimize all the statements in there. Okay, so invalid packages extends your outage. I have some people say, well, I'll just let autobind handle it, meaning as you run the packages, the ones that actually are getting executed will get rebound. But that's a little bit dangerous. You know, some of you have probably experienced this as I have, when you turn the application back on and everything jumps in and tries to rebind all the same packages at the same moment, you can end up getting tied in knots, and that's not good. It would be a good idea to do the explicit rebinds for the packages that you know are going to go invalid and that you know are actually being used. And fortunately, IBM a couple of years ago gave us a column in syspackage to help with this. You can go look at last used. So in other words, if there are 5,000 packages that got invalidated by you know, a change that you made, you can go and generate rebinds specifically on the ones that are actually being used. In other words, it's a date column. So you can say, all right, anything that's been run in the last week, we'll rebind those, at least do those first, right, and let the application come back up. And then anything else you can rebind more at your leisure, or just leave them invalid. It also helps if you can kind of keep your packages cleaned up a little bit, especially if you use package versioning. This can be an issue. All right, you could have dozens of old versions of packages that are no longer being executed and probably never will be. Better not to have to try and rebind all of those, you know, through one of these changes. So that you know, in my opinion, you want to do explicit rebinds of the things that are actually going to be run, and that last used column in syspackage can help you out. That's a big thing to think about, and something that, the first time somebody does one of these alters, might not come across their mind. This is advertised as, these are online changes now. We all know about the switch phase, but if you're left with thousands of invalid packages on the back end of that, something you may need to deal with proactively. All right. So that's what I got today. My email address is on the board. Also, you can find me on Twitter at ThemisDave or at Themis Training for Themis. I'm going to go back actually to the first slide that I tried to show you but didn't. There we go. Themisinc.com/webinars is where you can get slides from today's webinar. You can see replays of older webinars. They're all out there. You can also find some of my work at idug.com or idug.org, /content. There's all kinds of new content going out there every week. So I'd encourage you to check that out. Some of that's mine, and lots of other contributors out there as well. Most of that is free and available to you just for going to the website. Okay. So thanks for spending a little bit of your day with me, and feel free to use the email address there or the other ways that you see there to get in touch with me if you want to discuss further. Hope you guys all have a great rest of your day and week, and we'll see you when I do this again in March. Thanks.